Good morning everyone. Today we will start the topic electrolytic cell, other name it is voltmeter. We have already discussed about the electrochemical cell. So today we will discuss electrolytic cell. Okay. So which type of container it is, which type of cell it is? It is the device which carries the process of electrolysis or electrolytic decomposition. It means you have to give the electricity, then decomposition will take place. So electrical energy will convert into chemical energy. So according to the name only, it suggests electrical energy is used to break the compound. Okay. So voltmeter we can say na, it can convert electrical energy into a chemical energy. So in this cell we have to take only the one container. Okay. In that you have to keep two rods. One is anode, other is cathode. Okay, anode carry positive charge and cathode carry negative charge. In that you have to take the solution. Okay, if anode carry positive charge, then it will attract the negative ions. Cathode carry negative charge, then it will attract the positive ions. Okay, so with the help of this you can break the compound, and two ions, two separate ions, two oppositely charged ions, they will move towards the oppositely charged rod. Okay, so you can see here anode it carry positive charge. Okay, where oxidation will take place, whereas cathode is an electrode where reduction will take place. Here opposite word written here. Here we will write oxidation, and there you will write reduction. Okay, so always at anode oxidation will take place, and always at cathode reduction will take place. So anions are discharged on anode. What is the meaning of this? Anions it carry negative charge, means these are negatively charged ions, and anode carry positive charge. Then anions it will attract towards the anode. Cations it will attract towards the cathode, because cations these are positively charged ions and cathodes carry negative charge. Okay. So in voltmeter the flow of electron is from anode to cathode. Because why it is? Because anode always carry out the oxidation, and oxidation means removal of electron. So electron will move from anode to cathode. Okay, and current shows the opposite direction to the flow of electron. That's why current will flow from cathode to anode. Okay, so you can see here anode to cathode flow of electron take place, but cathode to anode flow of current will take place. So in this cell you can see here E cell is always negative and del G it is always positive. What is the meaning of this? Del G it is positive, it means it is non-spontaneous reaction. So non-spontaneous means you have to give the energy, then only reaction will take place. Okay. Neutral atoms are converted from the anions after reaching the anode by giving their electrons. Okay. So you can say na, during oxidation any element it will lose electron. Suppose Na, it will give Na positive plus electron. Okay, so you can see here na, so every neutral atom it is always losing a electron at anode. But opposite will take place at cathode. Why? Because cathode here reduction will take place, and reduction means gain of electron. Okay, so B positive ion it will take the electron and it will give B. So you can see here product formed in the above reaction at cathode and anode are called primary products. Okay, if only a single reaction will take place at anode and cathode, then it is called primary products. Okay, but if further reaction will take place after primary product, then you can say it is secondary change. Okay, so you can say na, secondary products are formed after primary change. This is called secondary change. So you can see here one term, preferential discharge theory. So what is the meaning of this? Suppose two ions are in competition with they can oxidize, which one can oxidize. So accordingly, how they will oxidize according to the preferential discharge theory. So what this theory said, it is according to this, ions is discharged on one which occur low in the electrochemical series, means which is having the lower lower position in the electrochemical series. Okay, it means you can say in a simple way, it need less energy, or it can say, you can say it need least energy with lower discharge potential. Suppose I will give you one example, paper and wood, which can easily burn. Paper, because it need less energy. Okay, so in the same way, if two ions they are competing with each other to be oxidized, then one which is having a lower position in the electrochemical series, that can be discharged very easily, or you can say which need less energy. Okay, less energy to be oxidized, that ions will oxidize first as compared to other. Okay, the potential at which the ions is deposited or discharged on the appropriate electrode is defined as discharge or deposition potential. Okay, so with the help of which potential it can be deposited, this is called deposition potential. So you can see here, for cations or for anions, these are the disposition potential given here. Okay, so what are the application of electrolysis, where you can apply it? Okay, so these are the application. First, production of hydrogen by electrolysis of water. It means you can use electrolysis of water, this process, for the production of hydrogen. For example, H2 you have taken, if you will carry out the electrolysis reaction for water, then it will dissociate into H2 plus O2. So you can say, no, you can produce hydrogen by hydrogen gas by electrolysis of water, or you can say oxygen gas also we can produce. Next, it is also used for the manufacture of heavy water. Okay, so by the process of electrolysis we can produce heavy water also. So what is the symbol of heavy water? It is D2O. What is D2O? D is, it is deuterium. Okay, that is the isotope of hydrogen. Three isotopes of hydrogen are there, and out of that one is deuterium. The metals like aluminium, magnesium, potassium, sodium are obtained by electrolysis of fused electrolytes. So by electrolysis of sodium chloride you can get the sodium. Okay, by electrolysis of potassium chloride you can get the potassium. Next application, non-metals like hydrogen, fluorine, chlorine are obtained by electrolysis. We have already discussed about the hydrogen. By electrolysis of water we can produce. Even silver, copper, these metals also we can produce by the process of electrolysis. Pure metal. During extraction process we are doing this process. Okay. Next, electroplating. So what is this? It is the process in which one metal is deposited over the other metal by the process of electrolysis. Okay. So you have done in earlier classes also that we can deposit the zinc on other element. Okay, by galvanization process. So this is that process, it is called electroplating. You can make a layer of one metal on the another. So why it is used? Mainly to prevent the corrosion. Okay. So in this process what you will do, cathode of an electrolytic cell is made by the object to be plated. Okay, so means you can say that metal which you have to be plated, that metal you have to make the cathode. Okay, another metal you have to make anode, which is going to deposit. So our next topic, it is Faraday's laws of electrolysis. Okay, two laws it is given here. So it was first given by Michael Faraday in 1833. Okay, so according to him, there were two laws, Faraday's first law and Faraday's second law. So in this also we are using the electrolysis process. Okay, So according to first law, what is the meaning of that? The mass of any substance deposited or liberated at any electrode is directly proportional to the quantity of electricity passed. Means how much electricity you will give. On that it depends how much amount of substance you can deposit. So W, it is directly proportional to Q. Q is the quantity of electricity passed in coulomb. How much electricity you are giving, that is represented by Q. So what is the unit? It is coulomb. As we know, we have already done in physics also that what is the relation between charge and current. So Q is equal to IT. So that only given here. Q is equal to current in amperes and time in second. So you can say now how much quantity of electricity you need, required, that is equal to I into T. Okay, how much current you needed in particular time. So according to first law of Faraday, how much amount of substance can be deposited, it is directly proportional to IT. Means how much electricity you will give, how on that it will depends how much amount will deposit. Okay, if you will remove the directly, then you will write here Z. So what is the meaning of Z? It is electrochemical equivalent. So Z, you can say here, as the name suggests, electrochemical equivalent. It means it is equal to equivalent weight of the substance divided by 96500. What is this? It is the Faraday constant value. Okay, and equivalent weight, it is equal to molar mass by n factor. So even you can put the value of Z. So here W is equal to ZIT. Okay. So now you can see here, coulomb is the unit of electrical charge. Okay. So 96500 coulomb, this much energy you required, this much electricity you required to deposit how much electrons? 6.023 into 10 power 23. So 1 coulomb required how much? If 965 required to deposit this, then how much 1 coulomb required? 6.023 into 10 power 23 divided by 96500. Okay, then its value comes out to be this much electrons. Okay, and we know a 1 electronic charge, it is equal to 1.6 into 10 power minus 19 coulomb. So you can put the values and you can find the answer. What if you want to define the electrochemical equivalent? W is equal to ZIT. So how you can define? Z becomes equal to amount of substance deposited. If how much current you will pass? 1 ampere. How in how much time? For a 1 second. Okay, so you can define Z, that is called electrochemical equivalent. So what is Faraday's second law? According to that, if you have taken the two cells that are connected in series and same amount of current you are passing through it, okay, then amount of substance deposited in both the cell is equal to their equivalent weight. Okay, suppose you have taken W1, then it is equal to E1. W2 you have taken, then it is equal to E2. Okay. So by using this formula, you can solve the numerical. So properly you can write this definition. When the same quantity of electricity is passed through different electrolytes, two electrolytes you have taken, okay, in a two cell that is connected in series, then mass of the different ions liberated at the electrode are directly proportional to their chemical equivalent. So simple thing, it is written here, amount of substance deposited, it is equal to their equivalent. Okay, so electrochemical equivalent of an element is proportional to the equivalent weight. So what is the value of Faraday constant? It is always 96500. Okay, and how you have solved this value? If you will multiply charge on the electron with Avogadro number, you will get the 1 Faraday. And 1 Faraday is equal to 96500. Okay. So Faraday laws for gaseous electrolytic product. So for the gases, what you can use, how much volume of gas evolved at any electrode at STP is equal to I current multiply with time. Okay, VE, what is VE here? Equivalent volume, means volume of gas evolved at STP, okay, by 1 Faraday charge. So this value you can use, this formula you can use for the liberation of gaseous electrolytic product. Okay. So in our next topic, we will read the topic electrical resistance and with their related terms. Thank you and have a nice day.